Do you feel ignorant because you don't know numbers? You don't know which one go which way and they got all these marks and things on them? I know, honey, it's hard, but there is a solution. Fort Bend Tutoring. And now here go Mr. Whit. Explain math to us, Mr. Whit.
Hello, ladies and gentlemen. This is Mr. Witt with Fort Bend Tutoring, FBT, and today's lesson is going to be about solving quadratic equations dealing with the zero-factor property. Oh, yeah. And basically, you're just looking at an equation, ladies and gentlemen, in the form of ax squared plus bx plus c equals 0, a quadratic equation, preferably in standard form, or it could already be factored out, like in x minus b times x minus c equals to 0. In other words, you want to have it factored, set equal to 0, and in that case, you could set each factor equal to 0 and solve for it. So in a problem like this, x would equal to b, and then x would equal to c. And basically, ladies and gentlemen, that's the zero-factor property, but that means nothing to you until you see some examples, right? So let's look at problem number 1. I have it right here, right underneath it. Let's check it out. In problem number 1, we have the quantity of x plus 3 times the quantity of x minus 4 equal to 0. So notice that we have two sets of parentheses multiplying against each other, and they're set equal to 0. Well, see, that's what you want. You want things factored and always set equal to 0 when using the zero-factor property. So once it's factored and set equal to 0, all you would need to do is set each factor equal to 0. So I'll have it rewritten as x plus 3 equal to 0 and x minus 4 equals to 0. And then you just solve for each equation. So in the first equation, I'll be subtracting 3 to both sides, which gives me x equals to negative 3. And then the second equation, I'll be adding 4 to both sides of the equal sign. And this gives me x equals to positive 4. Once I have these two solutions, and those are my answers, by the way, ladies and gentlemen, I can write them as a solution set. So if I can draw, oh Lord, I cannot draw a brace. Why can't I draw braces, ladies and gentlemen? All right, so if I take my time, there you go. There you go. That's as good as it's going to get for me. I cannot draw braces. It kills me. So what I'm going to do is I'm going to write my solutions in ascending order as though it's on a number line. So in other words, I'll be starting with the lowest number, the smallest solution, which is going to be negative 3, and then my largest number, which is going to be positive 4, and then there you go. All right, so that's your solution set. Those are your answers. Done and done. And I got my red box right there. So that's the zero-factor property. You start out with a factored quadratic equation. You set each factor equal to 0, and you write your answer in ascending order. Yeah, and that's it. Done and done. Okay, so here we go. Moving on to the next problem. Let's check it out. In problem number 2, I have the following problem. I have x squared plus 8x plus 15 equals 0. Now, the method that we're using, the zero-factor property, is best used when you have an expression that can be factored. So I would be looking to see if I can find two numbers that will multiply to give me 15 and add to give me 8. And so those two numbers would be? Well, very good. It would be 5 and 3. That's right. Now, if you have any difficulty factoring quadratic trinomials such as this, please check out our videos on factoring quadratic trinomials, part 1, part 2, and part 3. Yeah, they're very helpful, so check those out. All right, so here I'm going to open up two sets of parentheses. I'm going to make sure it's still set equal to 0. I have my variable x, because x times x gives me x squared. And we said that 5 and 3 would multiply to give us 15. And this last sign here will tell us to add to get 8. So both of these will need to be positive, and there you go. It's factored. Okay, but since we're solving the equation, we'll need to set each factor equal to 0 and then solve for them separately. So I have x plus 5 equal to 0. I also have x plus 3 equal to 0. And then I'll be subtracting 5 to both sides. Yep. Okay. And then x equals to negative 5. And then I'll also subtract 3 to both sides, and I'll end up with x equals to negative 3. So here are my solutions. And once again, I'll be attempting to draw a brace. So pray for me, please. Let's see. Oh my goodness, this is ridiculous. There you go. There you go. Nice brace. So we'll have negative 5 and negative 3. Okay, and we're going to deal with that brace right there. Okay. All right. Send in any strategies that you want to teach me how to draw a brace. I cannot do it. All right, so here's the solution. Negative 5, negative 3. So what do? We started out with our equation, x squared plus 8x plus 15 equal to 0. We factored the trinomial. We set each factor equal to 0. We had our two solutions, negative 5 and negative 3, and we wrote them in a solution set, writing the solutions in ascending order from least to greatest. Now, depending on your teacher, depending on whatever online website you may be using, they may not care what order your solutions are in. In other words, you can put the -3 first and it just doesn't matter what order it is. I'm just letting you know, as a mathematician and as a math student, it will be good practice for you to always write your solutions in ascending order from least to greatest. All right, so there you go. Moving on. The next problem we have, problem number 3. We have 5x squared minus 30x equals 0. So in this particular problem, I would like to let you know about a couple of strategies that you can use. For one, you always start by looking for the greatest common factor when you're factoring your trinomials or binomials or whatever terms you may have when you're trying to use the zero factor property. Always look for the GCF first. Another tip I would like to inform you of is that anytime you have a coefficient, meaning a number that they all have in common, all right, then you can just simply divide that away only when you're dealing with an equation. Okay, so this is different when you're just asked to factor an expression completely. Here, because we have an equation, we have something on either side of an equal sign, we can literally just divide everything by 5 because each and every term can be divided by 5 evenly, and we can simplify this equation. Yeah, I can just simplify this into x squared minus 6x equal to 0. Okay, notice how the x squared minus 6x equal to 0 looks a lot less intimidating than our original problem, right? Okay, that's because we simplified it. So you can always simplify an equation by a number, but never a variable. For instance, these two terms here, they also had x in common, but I didn't divide away an x. So never divide away a variable because that's dividing away a solution. So don't ever do that. You can simplify it by dividing everything by a number, however. Okay, so keep that difference in mind, please. So continuing on, these two terms have x in common, so I'm going to factor out an x. That'll leave me with x minus 6 equals 0. So here we have it completely factored out. And you could have just simply factored out 5x in the beginning, and that would have been a-okay, but I prefer simplified equations. It's just a personal preference. So here I'm going to set my first factor, x, equal to 0, and then I'll set my second factor, x minus 6 equal to 0, and then I'll solve for each. There's nothing left to do because x is already isolated. Then over here in our second equation, we can add 6 to both sides. Yep. And we'll have x equals to positive 6 as well. So, drawing the solution set. All right, so we have 0, 6 as our solution, and notice the ugly braces that, there you go, I can't do anything about those. All right, so 0, 6. That's the answer to problem number 3. Let's continue on. Problem number 4. In problem number 4, we have 5x squared minus 11x equals to -2. So what I want to do in this problem here is I want to first of all make sure that the entire equation is set equal to 0. And right now it's not. So I'm going to add 2 to both sides of the equal sign and rewrite this equation. All right. So I'll be rewriting this as 5x squared minus 11x plus 2 equals 0. From there, I want to factor the trinomial on the left. I want to factor that 5x squared minus 11x plus 2 if it can be factored. Well, I can find that out by multiplying 5 times 2. Well, 5 times 2 will give me 10. So I would be looking for two numbers that'll multiply to give me 10 and add to give me 11. Well, that would be 10 and 1. So I'm going to open up two sets of parentheses. I'll have my variable x, I'll have 10 and 1, and both of these will need to be negative. So these two numbers will multiply to give me positive 10 here, and also add to give me a negative 11. Once I have this initial framework set up, I'm going to divide both of these values by that leading coefficient of 5. All right. Now, this technique, ladies and gentlemen, I have plenty of examples on in my Factoring Quadratic Trinomials Part 2 video. So check that out if you've never seen it done this way. So you'll have x minus 2 times this denominator will go in front, and that'll be 5x minus 1, and that's all now set equal to 0. So I have it completely factored now. Once I have the equation factored, I can then set each factor equal to 0 and therefore solve the equation. So I'll have x minus 2 equal to 0. I'll have 5x minus 1 equal to 0. And then I'll solve for x in each of the equations. All right, so I'll be adding 2 to both sides of the equation, as well as I'll be adding 1 to the second equation. All right, that gives me 5x equals to 1. Then I'll divide both sides of the equation by 5. So I'll end up with x equals to 1/5. All right. So as a solution set, let's see. All right, that's going to have to do for that brace. I'll end up with 1/5 and 2 as my solutions. All right, let's see if I get this red box around here. All right, so to recap over that problem, we started out by setting the initial equation equal to 0 by adding 2 to both sides. We then factored the trinomial, all right, and you can use any preferred method you know of, all right, and then after that, once it's factored, you set each factor separately equal to 0 and solve for your variable. And I'm writing my solutions in ascending order, all right, from least to greatest. So I have my 1/5 and 2, and that does it for problem number 4. All right, let's check out the next problem then. For problem number 5, we have c times the quantity of c minus 11 equals to negative 18. And at first glance, a lot of students would assume this equation is already factored, but it's not. The reason for that, ladies and gentlemen, is because it's not set equal to 0, and you have to have it set equal to 0 in order to use the zero factor property. So instead, what you'll do is multiply. In other words, you want to distribute first. In other words, get those arrows popping. All right, my favorite property is the distributive property. So get those arrows popping. You'll end up with c times c, which is going to be c squared. C times negative 11 is negative 11c, and this is going to be set equal to negative 18. You still want to have this set equal to 0, right? So let's add 18 to both sides of the equal sign, and then we'll be able to rewrite this as c squared minus 11c plus 18 equals to 0. All right, you'll be looking for two numbers that multiply to give you 18 and add to give you 11. Those two values would be 9 and 2. So I'm going to have c minus 9 times c minus 2 equals to 0. Once again, if you're still having difficulty factoring trinomials, check out our videos, factoring quadratic trinomials. So then, after I have these factored, you're going to set each factor equal to 0. You'll have c minus 9 equal to 0. You'll have c minus 2 equal to 0. And then all I have to do from there is just add 9 to both sides to isolate my variable c. C equals to 9, and then I'll add 2 to both sides of the equal sign. This gives me c equals to 2. And from there, all I have to do is write it in my solution set. So let's see about those braces. Jacked up still jacked up. So you'll end up with 2 and 9. All right, that's it. Done and done. Just cannot draw a brace to save my life. Oh well. Next problem. We have problem number 6. Here, the equation is 2x cubed equals to 9x squared minus 4x. Notice that all three terms have an x in common, but you will not be dividing away an x. Remember that by dividing away a variable, you're eliminating a solution, and you do not want to do that. However, I do want to have this set equal to 0 first. So I'm going to subtract 9x squared and add 4x to both sides of the equal sign. So subtracting 9x squared, adding 4x to both sides of the equal sign. And if you wanted to, you can just break this first step down into 2 steps, meaning in your first step, subtract 9x squared to both sides and then add 4x in another step. But I'm doing it all at once because I don't have that much room to work with here. So I'm going to rewrite my equation as 2x cubed minus 9x squared plus 4x equals 0. Yeah, that's what's up. Then I'll be factoring out x as my GCF from each term. So factoring out x, I can rewrite this as x times 2x squared minus 9x plus 4 equals 0. Then looking at the trinomial, you want to see if this can be factored. So if I multiply 2 times 4, I get 8. And I know that 2 factors of 8 that will add to give me 9 is going to be 8 and 1. So this can be factored. So I'll be bringing down my variable x, opening up 2 sets of parentheses. I'll need an x and an x. And I'll use a negative 8 and a negative 1. Okay, because those will be able to multiply to give me 8 and add to give me 9. And then because I had a coefficient in front of my variable x squared, I'll need to divide both the 8 and the 1 by 2. Okay, always by that leading coefficient when using this method. Simplifying, I'll have x times x minus 4 times 2x minus 1 equals 0. Now that I have everything factored out, I'll be setting each of these 3 factors now equal to 0. So I'll have x equals 0, x minus 4 equals 0, and 2x minus 1 equals 0. And then you'll simply solve for each of the equations. So x equals 0 is already solved for. I'll be adding 4 to both sides. This gives me x equals to 4. I'll also add 1 to both sides in this last equation. This gives me 2x equals to 1, and then I'll divide both sides by 2, and this gives me x equals to 1/2, like so. So my final solution set is going to be 0, 1/2, and 4, okay? And that's it. That's the solution. Now there is something that you can use to gauge how many solutions you will normally end up with. Your highest exponent will always tell you the number of solutions that you'll have in an equation. Sometimes that means that your answers will be the same or that they may not even be real. However, you'll know the number of solutions to any equation by the highest exponent every single time. Alright, so that's problem number 6. Okay, ladies and gentlemen, here we have problem number 7. In problem number 7, I have negative 8n squared minus 16n minus 6 equals 0. So the first thing I notice is, 1, my leading coefficient is negative, and I never like that, but also that all of the terms can be divided by 2. So that means I'm going to divide every single thing by negative 2. Remember, it's okay to divide away a number, just not a variable. So I'll be rewriting this as 4n squared plus 8n plus 3 equals 0. So by dividing the original equation by negative 2, I was able to rewrite this original equation into something that looks a lot easier to solve, right? So here I'm going to start out by multiplying 4 times 3, and that gives me 12. So 2 factors of 12 that will add to give me 8 is going to be 2 and 6. So I'm going to open up 2 sets of parentheses here. I'll end up with n plus 6 times n plus 2, and then because I had that 4 in front, I'll divide both of these numbers by 4. So next I'll simplify, and I'll end up with n plus 3/2 times n plus 1/2 equals 0. Now if you're pretty savvy, ladies and gentlemen, since we're solving the equation, you could set these equal to 0 as they are, but I'm going to be consistent and show you what the completed factored form looks like first. So anytime you have any denominators left over when you're factoring using this method, those denominators will go in front of the variable. So you'll end up with 2n plus 3 times 2n plus 1 equals 0. Next, I'll be setting each one of my factors equal to 0 separately and then solving for my variable n. So I have 2n plus 3 equal to 0. I have 2n plus 1 equals 0. And then I'll subtract 3 to both sides in this first equation and then divide by 2, like so. So that I end up with a result of n equals to negative 3/2 for that first equation. And then I'll be subtracting 1 to both sides, and this will be 2n equals to negative 1, and then dividing both sides by 2. This gives me n equals to negative 1/2. So our solution is going to be negative 3/2 and negative 1/2. And that's it. Okay. Done and done. All right, that was problem number 7. All right, our last and final problem, ladies and gentlemen, is problem number 8. I gave you a lot of examples in this lesson here. Here in problem number 8, I have 63m squared minus 31m minus 10, and we're trying to find two factors of a master product of 63 times 10 that would subtract to give you 31. Ladies and gentlemen, I'm not going to be multiplying 63 times 10. That number's going to be huge. So instead, what I will use is the prime factorization of 63 and 10 to help me find factors that will subtract to give me 31. So looking at this, the prime factorization of 63 is going to be 3 times 3 times 7, whereas the prime factorization of 10 is 2 times 5. All right, and once again, ladies and gentlemen, this particular process that I'm showing you here is in our video, Factoring Quadratic Trinomials, Part 3. All right, so I'll be finding two factors out of these numbers here that will subtract to give me 31. So what I believe I'll use is the 9 here, all right, that 3 times 3 times this 5, and 9 times 5 is 45, right? What's left over is 7 times 2, which is 14, and 45 minus 14 is 31. Bingo, that's what I needed. So I'm going to open up two sets of parentheses. I know I need my variable m, and I'll be using 45 and 14. So remember, I got these two factors using the prime numbers of the original first coefficient and the last coefficient. I know that the 45 needs to be negative. The sign of the middle term is always the sign of your largest factor. And because I'm subtracting, the 14 needs to be positive. And I'll be dividing both of these numbers by that leading coefficient, which is 63. Yep. Remember, all of this is still set equal to 0. Simplifying these first numbers by 9, I'll end up with 5/7. Simplifying the 14 and the 63 by 7, I'll end up with 2/9. Remember, any remaining denominators will go in front of your variable, so you'll end up with this factored as 7m minus 5 times 9m plus 2 equals 0. Setting each factor equal to 0 using the zero factor property, we'll have 7m minus 5 equals to 0, as well as 9m plus 2 equals to 0. And then, solving for each one of these, I'll add 5 to both sides in the first equation. That gives me 7m equals to 5, and then I'll divide both sides of the equal sign by 7 to give me m equals to 5/7. So that's my first solution I got. Then, in this second equation, this 9m plus 2 equals to 0, I'll subtract 2 to both sides of the equal sign. I'll bring down 9m equals to negative 2, and then I'll divide both sides of the equal sign by 9, leaving me with m equals to negative 2/9. Alright, so those are my two solutions. As a solution set, it'll be negative 2/9 and positive 5/7. And that's your solution to problem number 8. Alright, ladies and gentlemen, that does it for this lesson of solving quadratic equations using the zero factor property. We kicked out 8 examples for you. How about that? Please rate, comment, and subscribe, ladies and gentlemen. And if you're able, please donate. We really appreciate it. Peace.
We certainly hope you enjoyed today's presentation by Fort Bend Tutoring. Did you understand the program? Would you like to rate us or give us some feedback or subscribe to us? You could do all that on tutormemath.net.